So in this video, I'm going to derive the Lever rule and use it to explain how the ratio of the vapor-liquid fractions change in a closed container of a binary mixture at a fixed temperature as the pressure is increased and the contents transition from all vapor to all liquid. So to help us kind of understand what is going on, I took a little picture of the graph that we made in one of the previous videos. And basically what this is showing is this is our dew pressure and bubble pressure curves. And these little dots in between are our mole fractions of the more volatile component in our mixture. So this yellow one is the mole fraction of the more volatile component, and then the blue and red ones represent the gas and liquid mole fractions of the more volatile liquid. So now we can start deriving the Lever rule, which we're going to start out with this equation that we used in a previous video. So T Zi equals V Yi plus L Xi. And now we can substitute for this T using this equation here and just substitute in V plus L. So it'll be V plus L times Zi equals V Yi plus L Xi. And now we're going to distribute the Zi out. So it'll be V Zi plus L Zi equals V Yi plus L Xi. And now we just want to get all the things with L and V on the same side. So we're going to do L Zi minus L Xi equals V Yi minus V Zi. And now we can just factor out the V's and the L's. So L Zi minus Xi is equal to V Yi minus Zi. And now finally we can divide through, so we will get V over L will be equal to Zi minus Xi over Yi minus Zi. And this will be our final Lever rule. Now I'm going to talk about what would happen if we were to increase the pressure in this situation. So if we were to increase the pressure, that would mean that this yellow dot would be moving up. And that means that our distance here, this white line, which corresponds to this part of our Lever rule equation of Zi minus Xi, this distance here would be getting smaller as we move this yellow dot up as we increase the pressure. And corresponding with that, our green distance here, which corresponds to the bottom of the equation, would be increasing. So that means that we would be getting more liquid until eventually it would be all liquid when we meet this line. And that would be true if we decrease the pressure as well, just in the opposite way. So if we were to decrease the pressure, the yellow dot would move down and the green line would become smaller, which corresponds to the bottom here would be getting smaller, in the top, our white distance would be getting greater up here, and that means that we'd be getting more vapor until eventually we met this line and it would be all vapor.